Alright, your survivalebooks.com. You can get this book. Subcourse 0D1006 Edition 6. U.S. Army Ordnance Center and School Wheel Vehicle Drive Lines Axle Suspension Systems. Alright, U.S. Army Lightweight Vehicle Mechanic MOS 63B Skill Level 3 Course Wheel Drive Lines Axle Suspension System Subcourse number OD1006. 5 credit hours. Ordnance School. Lesson 1, Fundamentals of Propeller Shaft Assembly. Describe fundamental propeller shaft assembly. Give information, construction, operation, maintenance, propeller shaft, and universal joints. Lesson 2, Fundamental Axle Assembly. Describe fundamental axle assembly. Give information, construction, operation, lubrication, maintenance of the axle assembly. Tip of the principal axle shaft principles, bevel gear, and differentials. Lesson 3, Fundamentals of Suspension System. Describe fundamental suspension system. Give information able about the construction, operation, maintenance, spring shock, absorber frames, bogey system, suspension system, tires and wheels. Table of contents. Alright, introduction to wheel vehicle drive lines. Alright, automotive drive lines. Let's see if we can't get this just a tad bit bigger. Automotive drive lines and suspension system have changed quite a bit since the first automobile was built. At first, automobile axles were attached directly to the main frame of the vehicle. This caused many problems. For example, the vehicles produced a very rough ride. Also, rigid construction did not work well on rough ground, but sometimes one of the wheels would not touch the ground. If the wheel off the ground was a drive wheel, the vehicle's lost traction stopped. The problem provided a need for the more flexible vehicles. The problem was corrected by using springs between the axle and frame. The early springs were of the same type as used with a horse and drawn buggy. They allowed the wheels and axles to move up and down separately from the body. The body moved very little compared with the wheels and axles, and the ride was much smoother. Allowing the axles to move separately from the body also kept the wheels on the ground over the rough roads. But this caused a new problem. The old drivetrain between the engine and the axle would not work. This train would have to be made to move more. This was done by adding movable joints in the drive shaft known as universal joints. Some of the early vehicles used only one universal joint on the drive shaft, while later vehicles used 2 universal joints on the drive shaft. Drive shafts are not usually called propeller shafts. Some long-wheel base trucks, known as many of the 4 propeller shafts between the transmission and drive axle. These propeller shafts are connected with a universal joint. Early automobiles were made with a body and power plant with a running gear. The running gear was made of the wheels and axle springs of the drive shaft of the transmission. The transmission was often mounted midway between the engine and rear axle, connected with the engine and rear axle of the drive shaft. The term running gear is not used anymore. A new term chassis is noted to identify the old running gear plus the power plant. In modern vehicles, the transmission is generally mounted on the engine as part of the power plant. The chassis is the modern military tactical vehicle, especially for the frame, spring, and axles, but is very strong and quite flexible. We will learn how to this is possible in the subcourse. Alright, lesson 1, fundamentals of propeller shaft assembly tasks. Describe fundamentals of propeller shaft assembly conditions. Give information about construction, operation, maintenance, propeller shaft, and universal joints. TM reference TM9 8000. Learning and describe the construction, operation, maintenance of the propeller shaft and universal joints. Propeller shaft vehicle equipped with a transfer case. Power is transferred from the vehicle transmission to a transfer case assembly by the power shaft. Just rear axle, front rear axle, rear axle, propeller shafts, transfer case, and transmission front axle. Propeller shaft is also called a drive shaft. However, the propeller shaft is a more common name. Some of the repairs shorten this to a prop shaft. The illustration shown with the power transmission, including the prop shaft or the propeller shaft, is one type of the wheel vehicle known as the forward propeller shaft. Is used to drive the vehicle. One transmits torque to the transmission transfer case. One delivers rotary motion from the transfer case to intermediate differentials. Another delivers rotary motion from the intermediate differential to the rear differential. Fourth delivers torque to the front differential. Propeller shafts made of many different types of size and strength, depending on the needs of the different type of vehicles. One end of the shaft is built with a house universal joint. The other end is usually splined into a slip joint. Shafts that may be made with a solid steel may be hollow or tubular. A hollow propeller shaft is usually preferred. Twisting and forcing torque applied with the one end of the shaft and is transmitted through the shaft of its open ends. The strain stress created with the shaft range with the minimum of the shaft rotated center or axis to a maximum at its outside surface. Since the center part of the shaft carries a small port, a low tubular hollow propeller shaft is used whenever possible. Solid shaft is stronger than the tubular shaft of the same thickness diameter. The tubular shaft, however, is much stronger than a solid shaft of same weight and length. So it shows the axle assembly, slip joint, sliding yoke, drive assembly, fixed yoke, slip joint, spline. The power transmission must be flexible between the spring of the vehicle for the suspension system. As the spring flexes, the axle assembly will move backward and forward, up and down, with the causing angle of the distance between the axle and assemblies and transfer cases constantly change. Slip joints, universal joints, and instead joints are installed with the propeller shaft, provide flexibility and permit these changes of the power transmission system. Alright, a slip joint at one end of the propeller shaft allowed the propeller shaft to lengthen and shorten with the position axle change. The typical slip joint has a male and female spline. It may usually contains a lubricating fitting and an oil seal, but the male spline is part of the propeller shaft. Female spline is fixed to a universal joint. The slip joint is then located with the power input of the propeller shaft at the end of the transmission, if allowed with lengthwise freedom of the movement of the power propeller shaft of the transmit rotary motion. Universal joints. Construction operation. Universal joint is flexible between two shafts that permits one shaft to drive with another angle and transmit power with the angle between the shaft is constantly changing. Figure 3 shows your universal joint. Shaft pivot, yoke, shaft pivot, journal. A simple universal joint consists of three basic parts: a journal and two yokes. The two yokes are set crosswise at right angles of each other. Their openings ends joined by journal. Construction permits each yoke to turn pivot on the journal while the transmitting rotary motion from one yoke to the other. A universal joint must be designed to overcome the natural disadvantage of the rotation angle. With a simply conventional universal joints cover the drive shaft, speed up and slow down twice during each of the turn with respect to the drive shaft. The amounts of changes and fluctuations depends on the amount of the angle between the two shafts. The angles between driving and driven shaft is increased with speed changes increases. This shows your speed fluctuation chart. One revelation per propeller shaft, driving shaft, 30-degree angle. Alright, when the shaft is at a 30-degree angle, the fluctuation speed with a maximum 30% of the driving speed of the drive shaft fluctuates between 850 to 1150 RPMs. The speed fluctuation transmitted with the axle assembly would be placed in the powertrain parts. In addition, the steady force would not be applied with the driving wheels. Speed fluctuation can be eliminated with a simple universal joint. This affecting using two joints at one end of the shaft. Fluctuations created by one joint will be canceled out by the other. However, certain conditions must be met with the force installation will take place. The angle between the transmission output shaft and the propeller shaft must be made the same as the angle of the propeller shaft with the axle assembly input shaft. In addition, two yokes and propeller shaft must be aligned with each other with arrangement of the one joint turns the great speed with the second joint turns the slow speed. This is a result of the allowing constant output speed to the driving wheels. The speed of the propeller shaft between the two joints, however, still fluctuates. Alright, types. The universal joint bearings include with the 4 points over the journal is attached to the yoke with several different kinds of journal type of universal joints. The main difference among them is the way the bearings are attached to the yokes. So type 1 shows your joint universal with a spline, split joint, journal, clamp bolt, flange yoke, locking plate, nut, and slip yoke. Consider the universal joint shown in figure. The journal is placed in slip yoke with the bearing assembly with its insert of the outside secured with the spring retainers and called snap rings inside of the yoke. The bearings on the other side of the journal are secured with a flange yoke by clamps and clamp bolts. This shows your figure 6 showing another type of the journal universal joint, slip line joint, slip yoke, bearing assembly, bolt, flange yoke, journal bearing block assembly. Universal joint shown differs the way of the attached flange yoke in the joint and two bearing assembly contained with the bearing blocks. The blocks are mounted against the flange yoke secured with the bolts sending through the flange and bearing blocks. Alright, figure 7 shows the ball and trunnion universal joint, the dust boot with the body of the ball with the companion flange, compensating spring, ball, and propeller shaft. Another type of the universal with a joint with a ball and tuning with the universal joint itself contains the feature eliminated the need a slip joint with the cutaway. Notice the cutaway view with the ball and tuning universal joint. In this type of the union with the tuning pinion is pressed through a hole with the end of the propeller shaft of the pinion is fitted with the ball with the ride with the groove with the flange body. Balls are assembled in the bearings so that they rotate with little friction. Compensating springs at each end of the propeller shaft hold the shaft with the center position. Changing the drive length with their permitted with the endwise movement of the balls and body groove, the chain with the angle between the shaft that are made possible, the inward outer movement of the balls and tuning pin with the balls and tuning the universal joint easily recognized with the flexible dupe bus that covers the propeller shaft end. Alright, maintenance and propeller shaft universal joints inspection procedure. Serviceability of the propeller shaft, the lip joint, and universal joints can be determined by the inspection which they are installed with the vehicle. In general, these parts are inspected same manner of all vehicle with a propeller shaft, proper shaft, with inspected with the place for the chocks and in the front and rear with the front wheels ready with the wheels connected with the propeller shaft being expanded so the wheels free eternally. Lock the propeller shaft over carefully with a big dents that will cause the bent out with the out of balance. Inspect with the brake the crack with the welded seam at the end. Clean off the excessive dirt that may be stuck with the shutting of the shaft causing an unbalance. Check for proper mounting, making sure the propeller shaft is installed with a slip joint nearest to the transmission. Also make sure the yokes at the end of the propeller shaft are aligned. Examine the slip joint oil seal, universal joint. Make sure the slip joint oil seal cover is placed in tight. Universal joint mounting bolts must be tight and must have no strip threads. Check universal joint bearing cracks. Cracks will usually occur with the bearings inside of the yoke. At this time, inspect for the missing cracking bearing grease seals, which will also inside of the yokes. Look for the broken missing bearing retainer snap rings. Alright, universal joints and slip joints should be properly lubricated before you inspect the looseness. Lubricating the joints according with lubrication order for a particular vehicle that you're working on. All grease fittings have been damaged badly should be replaced. The fitting should also be replaced with the grease. Do not pass through easily if the grease comes from fitter after the grease gun is removed. After lubricating, shake and propeller shaft. Note any looseness. When the handbrake is applied with the wheels off of the ground, attempt to rotate the propeller shaft back and forth. Again, noting any of the looseness. No looseness is allowed in the universal joint bearings, but a very small amount of slack is normal at slip joint splines. Placing the transmission in neutral and unturned propeller shaft hand. Listening for squeaking, grinding, grating sounds. These noises indicate improperly lubricated defective bearings. Then it has the questions. A blank page, your answers, and we're moving on to fundamentals of the axle assembly. Testing.